Hey everybody, this is Mark. It's actually my first video, and you can't see my face. I'm just demonstrating the easiest way I found yet to make graphene. And I don't know, it just struck me one day that I was actually at my other job being bored, and so I came up with this method of exfoliating graphene from essentially aquarium charcoal. And I ordered some stainless steel screens, some mesh like they use for the vape machines, and this mesh is like 400 mesh, and I got two pieces of picture frame glass from a couple of picture frames I got at Goodwill for 50 cents a piece, and I put them in this glass. I found out that trying to work with graphene, it's really important to work with glass because you want to be able to wash it up clean. And when I had the plastic blender and I was trying to make it in a blender, it was getting a mess everywhere, and anyways, it's difficult to clean up, and the plastic blender thing is permanently ruined. Anyway, so I switched to glass blenders, and then I watched a video from Robert Murray Smith, a pretty good chemistry guy, and he said that the blender method of making graphene actually damages the carbon. So you don't really get good graphene that will lay in a nice six octagon mesh. So anyways, to really get real good graphene, this is the I have a website called Mr. Fission, and it's kind of just a funny characterization. But anyways, this is actually using fission or electrolysis to exfoliate. Those are big $50 words, but to exfoliate graphene from the graphite or carbon by what I've done is I've taken two sheets of glass, and I silicone the edges of the screen, the stainless steel screen, and so you essentially have a capacitor, two sheets of stainless steel screen. The stainless steel will not dissolve in distilled water or ionized water, and so you have to use distilled water because electrolysis will pull the mineral salts out of tap water. So you cannot use tap water. You have to use distilled water. And you don't want the two plates to short. So essentially this glass tray, I have the tabs of the glass tray. The positive side of one screen and the negative side is the other screen. It doesn't really matter if it's the top or the bottom. It doesn't matter. But what I do is I sandwich like a capacitor. I put the activated charcoal granules in between, and then I just kind of set, here, it's terrible, but I'm doing this on an iPhone. But, just one of the things that happens is, the bubbles will, nitrogen and oxygen bubbles, off of the two plates will build up and try to lift lift one of the plates a little bit, when it's bubbling. So it's good. I took, this is the glass jug from the blender or whatever experiment, and I'm going to set this, I see all that hydrogen and oxygen mixture just bubbled up when I set the weight. The weight is it's sitting a weight down on top of the plate so that you get conductivity between the graphite. So essentially what you're doing is you're shorting the plates with the graphite, and by putting electricity through the graphite, you exfoliate the graphene from the graphite. In other words, you want to delicately shave off or carve off the graphene flakes from the graphite or from the carbon, and without smashing it or ripping it or grinding it. the best, most delicate way to actually get the graphite to come off so that it will reconnect in its natural lattice form. Which is, it likes to, be in a six-sided, cube or whatever. Sometimes you get 7, sometimes you get 5, but essentially six-sided is the natural state of graphene. And so, I'm just trying to get real graphene, not ground up carbon, because I'm working on a battery idea, literally using Coca-Cola and aluminum foil and graphene. So anyways, talk about a totally non-toxic, battery if it works. So, we'll save that for another video. And, my talking, and it's just like, here we are almost 5 minutes, and it's pretty boring, but, it was watching the bubbles come up. But I just wanted to explain how, I'm making graphene. It's exfoliating graphene using electrolysis or fission, whatever you want to call it. But I'm using electricity to, 12 volts from my little 12-volt battery jump starter that you can kind of see here. And then I sort of measure what my voltage is, and actually when you put a little bit of pressure on there, you get some more conductivity, which means you get a voltage drop, and it can drop down to 11 volts or 10 volts, whatever. It's going to eventually drop down when it runs out of current on this somewhere around, I don't know, I think it's about a 7 or 8 amp hour 12-volt battery inside there. And you can use any kind of a power supply. You could use, you could use like a wall wart, like a 1 amp 12-volt wall wart that's DC. I like batteries because batteries are really smooth DC for, electrolysis. And, it's just a good way to make sure that you're actually doing what you're supposed to be doing. You're trying to make the graphene, flake off of the existing carbon molecules and essentially just dissolve it into the distilled water. Later, you can actually add, when you take the voltage off, you can add the, let's see here, I'll show you my 91% isopropyl alcohol. You add that to the water and then set it outside and let it evaporate. And then, this is what's in the bath right now is just, Walmart brand distilled water and the charcoal. And so, by letting the charcoal sit here and basically dissolve with the using 12 volts and, the fission process of electrolysis, this jug is really just a weight on the plate so that it, displaces the bubbles that, are sitting there as my graphite is exfoliating into graphene. And since this video is now getting pretty close to 9 minutes, you're really probably bored to tears, so I'll sign off. And this is my first YouTube video, or my second YouTube video actually. You can look at my old YouTube video, 403 Mark. And it's, I was a television manager and I sold a TV station that I worked at. So anyways, long story short, there we go. Now we're almost up to 9 minutes. And I'm sorry if I bored you. So, just stay tuned and I'll try to come up with some more results of my process here. Okay?